Hey guys, so I want to talk about Verifiable, Doom, and Beyond, and designing RIVES, which is an Onchain game console. Just a quick intro on me, Max. Some of you guys might know me from Cortese. I was doing BD there for 2 years. I was also hosting the game builder calls where I had some of you guys come in and present what you were building. Playman, we had David, we had Guilty on. It was a great way to understand your theses and also understand how your theses evolved over time and like what your experiences were building on-chain games and what other people could do. So that was really interesting, and I'm glad to be here on stage today to share my story a bit. In January, we started building RIVES, which I want to talk about a bit today. To start, as you guys know, Doom is kind of like a staple game, like had a huge impact on the game industry. In multiple fronts, right? With 3D graphics, on the modding side as well with the Doom engine. The Shara model kind of took off for Doom. And it also had things like demo files, which are quite interesting, which are kind of game logs that were stored, kind of pre-even streaming or gameplays being on YouTube or something like that. So it was kind of really ahead of its time. It was also ahead of my time because I wasn't born yet, really. But I know Doom today as like something that runs everywhere on this Kodak machine, on iPod Nanos, and apparently also on a Bacteria now. So you could ask, why hasn't anyone put it on chain, or why not put it on chain, right? And up to recently we had limitations. Probably most of you guys are familiar with this. We had this limited compute power on one hand. Ethereum as one computer running everything, every single transaction. It would be very expensive to run it on it. And we also had limited programmability. We have the EVM with its own flavor of machine code, Solidity, which makes it a bit hard to port, old games or existing software. But that has changed. We now have rollups that actually scale computation, move computation off chain, and allow us to run things in a way where we don't necessarily have to compete for block space. We also can move from kind of this world computer to, I like to say, like a universe computer, where now we still have Ethereum as the sun in the center, but we have a bunch of planets with their own sort of environments, with their own atmospheres, which can breathe new life forms and new types of programs. So we have, for example, Starknet with Cairo, which is optimized for proving. We have stuff like Aztec, really focusing on privacy. And we have a couple also general purpose environments, including Cortese, but you also have Stylus by Arbitrum and Fluent doing stuff like Wasm, right? As I said, I worked at Cortese for a bit, so we actually decided to build RIVES on Cortese. And in short, Cortese aims to emulate a full computer, and it does that by emulating a RISC-V instruction set architecture in a deterministic way. And it can just boot an OS like Linux or a certain distribution like Ubuntu on top, which comes with a lot of advantages because you can easily port stuff that would run on a computer traditionally, and run that in a verifiable manner. On top of that, it's app specific, so you're not competing with any other application for block space. You have your own CPU for yourself. So we managed to run Doom on it by compiling it to RISC-V. A couple modifications, but it works. And we're taking a local first approach, similar to what Guilty talks about in his article, with Mew and stuff like that. We run it locally in the browser, compile the same RISC-V VM into Wasm, and can thus capture every single move that is made by the player. It's then submitted with the log file on chain and is rerun on the rollup where a bunch of nodes run the same VM with the same game and with the same log file to verify if your claimed result is actually the right one. Now, you might ask, why run it on chain? I think, if people run it on fridges, we should also run it on chain, but there's also a bunch of new affordances maybe that we can unlock, such as, you can actually now own your speed run We now have attributable and like a timestamp that corresponds to your gameplay, which is quite unique. I think Balaji uses the term crypto history, and we can like kind of build out this history. We know who did a certain set of moves first. I think that alone is interesting. But we also have, blockchains allow us to sort of coordinate around a set of rules and enforce them. So we can have, trustless contests. We can have custom rules potentially, and maybe other things as well. TBD. Like just an example of how we've been thinking about sort of different rules and tournaments. Every gameplay sort of comes with data, right, that is outputted. We call it an out card. And this can be sort of defined by us or the developer. And in this case, you can use this output to define, for example, okay, I want to create a score based on how fast you go, right? I don't care about how many people you kill in the game. I just want to know, okay, how fast are you going through it? So speedrun rule could be possible. You could have an assassin rule, and that allows you to sort of extend the game in sort of an infinite amount of ways. And obviously, what comes after Doom? It's obviously Call of Duty, right, or Counter-Strike, of course, or maybe not, right? We think that AAA games are great, but they're also all optimizing for graphics, and like it's these cinematographic games that are being built. You could argue, are they really fun to build? Do people enjoy building them? It feels a bit like they're built in these big factories where people have specialized knowledge in these game engines. Often they look kind of alike. Would hear the example of Call of Duty being like sort of a clone of every single previous one. Game mechanics are not always that interesting or that innovative, and the games are not always creative. But if you look at actually like retro consoles, they were really simple to build on. They were more low level. You sort of had this end-to-end process you could own. You could understand what was going on. And so we thought this was a bit more interesting. You also have existing fantasy consoles like Pico 8, which are emulating something that doesn't exist physically. It's a new environment, and they have tremendous, really creative games built on it, where the games feel like art. They're made with love. And we want to do something similar with RIVES, but put it on chain. So continuing what I was kind of describing with Doom, but make sort of a way for other people to build their own games and or port games. The way it works is that it's its own app-specific rollup using Cartesi. It runs a custom OS. Since we can run Linux distributions, we have a modified version of Alpine OS running inside of the Verifiable emulator. And people can build these small RISC-V programs, which are cartridges, and run them inside of RIVES. We also define some constraints to like limit the amount of choices you should make or could make, because often choices get confusing, and you just want to build something fun and create. And by having these constraints, you're forced to think within the limited resources, and you advance faster as well, and you might create something actually more unique. And we're also focusing on single-player games at the moment. A quick example about how the API works, where you draw hello world in C. So we define the colors, we define the location. I'm going to skip this for now. And now you might ask, like, what are the new affordances that why would we put this on chain? The way we're thinking about it here is that you have cartridges, which are sort of programs, and people interact with them, and their verified interactions become tapes, which are the demo files that Doom had as well, but this time they're sort of enshrined on chain. These tapes are essentially all your moves, your logs that can then be replayed later on in the same emulator. So it kind of replaces videos almost. And they also have interesting properties because they might be usable in the future, right? Where you could jump to a specific moment in the state, or maybe you're in a drawing app and you're designing a sprite, and this sprite is your tape, and you could use that tape as a character in another game So those are things that you could think about, and it's still we don't have that yet, but it's something that could be enabled by such a primitive. And yeah, and a leaderboard, obviously, right? Now, I know composability is a big topic in autonomous worlds, and just trying to think like what could a composable console look like, right? I think there's two sides. There's a gaming side, which I briefly mentioned. We have custom rules, functions, maybe also game modes where people in Pico 8, what is cool is you play the game and you can directly jump into the code, so you can see how certain mechanics work. And so kind of having that as a native thing could be really interesting, where people can play and directly sort of put their spin on a game. Obviously, there's like the whole incentives topic, like how do you reward modders, that might come into play, but that's a topic for another day. On the console side, we have this core mechanic, which is the verifiable gameplays, but people should be able to build, add modules to RIVES. So maybe GG Quest could add an achievements module, or we built the sort of basic leaderboard and tournament module, but anyone could build and extend the console as well, right? And we use MUD at the base layer for this like meta composability layer, which is, I think, not how you usually use MUD, but the guys thought it was a good way to use it. And yeah, that's my talk. I'd love to hear any thoughts or questions from anyone. And you can follow me on Twitter or check out Discord or Twitter. And we do regular game jams. I think last game jam we had a few people join, and they would be able to build a small game within like 10 hours on average, which is, yeah, you could build your game in any language that compiles to RISC-V, and people had fun. So I like to say the ultimate game maybe is to actually build your own game. So our goal is a bit like to reduce the constraints to actually build and get even players to create. Thank you. Any questions or thoughts? Yes.
Yes, so when you take, I don't know how to work, so I imagine some part of it is like the internal logic, the other is like the rendering. So do you have to like separate that and only put like the internal logic on chain?
Yeah, so in this case, we put everything on chain, including the graphics. So we could optimize it further, but since we're running things optimistically, and we have the VM on the WASM, like the WASM compiled VM on the browser and on the node, it's actually much easier for a developer to just.
Like an array, like the value of the pixels on like the screen.
Yeah, I think so. Yeah.
And you just like render that thing.
Yeah.
Locally, and then, oh yeah.
Run locally, yeah.
Makes sense.
Yeah.
When you put the cartridge on chain, is that the source code or is that the compiled down provable risk?
Oh, it's the actual cartridge, but it's compressed, and it's not put on the base layer. It's still like within the rollup, right?
Right. Okay. Yeah, just wanted like because the cool composability things you can get by sharing code with modules. I think you need source code.
You do need the source code, yeah. You get. So the way we're thinking about it is that so you would have everything in the rollup, and there's this concept called cascades. It's very like Cartesi specific, but you would essentially rerun the specific proving inside of another rollup, and then you would essentially have access to that data as well. So you would kind of like mirror the rollup. For example, in the case of a tournament application, you would, or an NFT, sort of, imagine if you want to mint an NFT every time someone plays, you could wait for settlement on the base layer and then do it. That sucks. Or you could have a sort of mirror of the original DApp running inside of your rollup, your other rollup, and use that as sort of your input.
Cascades.
Cascades.
We'll get to that.
Yeah. Cool. Thank you so much, guys.